Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our third lesson on the extreme values of a function. In the last lesson, we learned about Rolle's theorem and the applications of the mean value theorem. Today, we are going to learn about the local extreme values of a function on its entire domain and the first derivative test. This should be an interesting lesson. Are you ready to get started? Do you remember what we have learned about critical numbers, students? We learned that if f has a local maximum or minimum at c, then c must be a critical number of f. But not every critical number gives rise to a maximum or a minimum. Because of this, we need to think of a test that will tell us whether or not f has a local maximum or minimum at a critical number. Let us suppose, then, that a function is continuous on a closed interval a, b. C is in the interval such that f is strictly increasing on the closed interval a, c and strictly decreasing on the closed interval c, b. Such a function would look something like one of these two graphs. Illustrated this way, it becomes obvious that f of c is greater than or equal to f of x for all x in the closed interval of a, b. So, f of c is a local maximum value of f on the open interval of a, b. We can make some further observations of these graphs that will help us think of a test for maximum or minimum numbers. f prime of x is greater than 0 for every x that is part of the interval ac and less than 0 for every x that is part of the interval cb. If f prime satisfies these conditions, we can simply say that f prime changes signs at c from positive to negative. The inverse relationship also exists, as we can see from these graphs. In this case, f of c is less than or equal to f of x for every x that is part of the interval AC, and greater than or equal to f of x for every x that is part of the interval CB. Can you guess what we may conclude about the derivatives of such a function? That is right, students. F prime of x is less than 0 for every x that is part of the interval of AC, and greater than 0 for every x that is part of the interval of CB. Once again, we may say that f prime changes signs at C from negative to positive. Because of these relationships, we can figure out a test for local extreme values of a function. If f prime changes sign from positive to negative at C, then f has a local maximum at C. If f prime changes sign from negative to positive at C, then f has a local minimum at C. If f prime does not change sign at C, then f has neither local maximum nor minimum at C. This is called the first derivative test. Apply this test for yourself, students, by seeing if you can determine the local minimum and maximum values of this function. Here's a hint. Use a sign chart to help you find your answer.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Did you manage to apply the test properly? First, let us differentiate the function. F prime of x equals 4x cubed minus 12x squared minus 16x. Factorizing the derivative, we can write it as 4x times x minus 4 times x plus 1. Now we are ready to make our sign chart. Yours should look like this. Using our sign chart as a guide, we can see that f prime of x is less than equal to 0 on the half open interval -infinity, -1, and the closed interval 0, 4. F prime of x equals 0 only at x equals -1, 0, and 4. We can draw certain conclusions from these observations. We may safely say that f is strictly decreasing on the half-closed interval -infinity, -1, and the closed interval 0, 4. As a result, f prime changes sign from negative to positive at -1 and 4. F of -1 equals 2, and f of 4 equals 123, which are the local minimum values. F prime changes sign from positive to negative at 0, and therefore f of 0 equals 5 is the local maximum value. I hope that you found the same answer, students. Are you ready for one more activity? We must get a great deal of practice applying the first derivative test. Find the local maximum and minimum values for this function.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I hope that the first derivative test was easier for you to apply this time. We begin by differentiating the function. So, f prime of x equals 2 minus 4 sine x. When f prime of x equals 0, we can rewrite the expression to find that sine x equals 1/2. Therefore, x equals pi over 6 or 5 pi over 6 on the interval of 0 to pi. Now, let us make a sign chart. There, we are ready to find the local maximum and minimum. Do you see the answer? From the sign chart, we can observe that f prime changes its sign from positive to negative at x equals pi over 6. Therefore, f of pi over 6 equals pi over 3 plus 2 times the square root of 3 is the local maximum value. In addition, we can see that f prime changes its sign from negative to positive at x equals 5 pi over 6. Therefore, f of 5 pi over 6 equals 5 pi over 3 minus 2 times the square root of 3 is the local minimum value. I hope you managed to find the same answer. If you ran into any trouble, please ask teacher to review your work. That brings us to the end of the lesson. Today, we have learned how to find local maximums and minimums using the first derivative test. Until next lesson, thank you, teacher. Thank you, students.